Hi friends, this is your friend Patodia. I am from IIT-JEE and I have been associated with askIITian for the last 2 years as Maths IHE. In this video lecture, the topic will be Parabola, which will be divided in 11 parts, and in the first part, we will be studying about the conic sections from where the parabola comes. We will also learn in this that how we can recognize a particular conic and what conditions leads to the parabola. Let us start with the first topic. Starting with the definition of conic section, it is a curve formed by the intersection of plane and a double cone. What it means? It means we are like cutting the double cone using a plane at different orientations, and according to the orientation, whatever section we are getting, that we classify as a conic section. So basically, broadly speaking, there are 4 types of conic sections. One of them is circle, which is the most simplest conic section, which is being obtained when we just cut the cone parallel to the base. When we incline the plane to some angle, it becomes ellipse, and as we are increasing the inclination and it becomes parallel to the slant height, we get a parabola, which we are going to study in detail in this video presentation. And the last one is the hyperbola, which is when we are cutting it perpendicular. We'll see this in more detail in the next slide, that how these conic sections are being cut. So as shown here, the 4 conic sections are being displayed. Let's see how we are getting the 4 conic parts: the circle, ellipse, parabola and hyperbola. So as I mentioned, if we cut it to parallel to the base, we are getting a circle. So this was the intersection parallel to the base. Now when we cut it at an other angle, we get an ellipse. Now as we are increasing the angle and cutting it parallel to the slant height, we get an parabola. And when we cut it perpendicular, yes, like this, we get an hyperbola. So these are clearly 4 things. As you can see, this is perfectly displayed here: circle, ellipse, parabola and hyperbola. So let's see. This is again now defining in mathematical terms that what is a conic section. So geometrically it was part of cone, but there must be a common property to every part. So the conic section defined mathematically is a locus of point which moves such that the ratio of its distance from a fixed point and a line is constant. So depending on that constant, the particular conic section is being classified, and the fixed point as written here is known as focus, and the line from which it is fixed distance, that is directrix. So as we can see in this is our point, okay, and this is the fixed line, the directrix, and this is the fixed point, okay. So we are saying this is moving such that this ratio by this ratio is constant, and that constant is known as eccentricity. So based on the eccentricities, we classify our cone parts of conic sections: a circle, ellipse, parabola and hyperbola. So as I mentioned, the fixed point is called focus, and the straight line is called directrix. The constant ratio is called eccentricity, and when the eccentricity is 1, eccentricity basically is the measure of circularness of a conic. So for circle it is 0. Why? Because it is perfectly circular and it does not deviate from that thing. So eccentricity measures basically the deviation from being circular. So for parabola it is 1, for ellipse it is less than 1, and for hyperbola it is greater than 1. The line of symmetry, as you have seen that every conic was symmetric along a line, that line is called as axis. The intersection of axis with the conic is known as vertex. We will study these terms later on in more detail. This is for your information so that you can keep it with you. So this is the second way of distinguishing between the conics. Earlier we classified in terms of the ratio. Now if any second degree equation is given, then how do we classify it as a particular conic? So for that, if we go back again to, if you remember what I said in that, PS over PM is equal to E. So in that, what we were saying, this is a point, fixed point, or this is a moving point, and this is the fixed point, suppose h comma k, and this represents the line. So now if you substitute the values like distance of suppose d1 and this is d2, so d1 we can find from distance formula and d2 will be the distance from a straight line. So if we equate it, so we will finally get a general equation of this form. So this will represent different conic sections depending on the conditions given below. So it will represent a pair of straight line if this delta equal to 0. Now the value of delta is given by this expression. This you can easily remember, A, B, C coefficients and then FGH, and obviously twice is there, so it will be there, and A is coefficient of X with Y, B is coefficient of Y, it will be with X. So this way you can remember using different methods. So it's one expression that you have to remember. It will represent a circle. Clearly for circle there is no this term, only A and B should be equal to 0, that everybody of us know. For parabola, h square minus b. Now this is something important to remember, that for parabola h square minus ab should be equal to 0. If any conic is given in terms of second degree equation, first you will need to check delta, that it represents a pair of straight line or not. If not, then this quantity h square minus ab. Now this will be more clear once we do one example based on this. So which conic does 13x square minus 18xy plus 37y square plus 2x plus 14y minus 2 represent? Now comparing it with this, and remember to write this 2hxy. Students, they make mistake in this. So this will be 2gx plus 2fy minus 2 equal to 0. Now you can write by comparing a is equal to 13, b is equal to 37, c is equal to minus 2. Then you have ABC I have written, FGH. So F is the coefficient of y, which is equal to 7, G is 1, H is minus 9. So these quantities I have written. Now we will check this expression, ABC plus 2FGH minus A with the coefficient of y, AF square, minus B with coefficient of this thing and minus CF square. So now if you check whether it is equal to 0, if it's not equal to 0, then we will check for that condition, h square minus ab. So in this case, after solving and putting the values, you will get this as minus 1600, which will be not equal to 0. So now we will need to check for this relation. So clearly h square will be equal to 81 and minus ab. So clearly this will be less than 0. This is greater than 81 obviously, and for this, if we remember, this will be an ellipse. So as clear from here, for ellipse this was the condition. So you can check that just sometimes the questions in mains, they appear on this form, and you need to remember that how do we classify the various conics. So I hope the concept of conic sections is quite clear now, and the video and the question which we did at the last, they were quite useful in consolidating the concepts. And again, key points which I mentioned, please keep that in mind. And in the next part, we are going to start with the introduction of parabola. In that, we will learn about the key terms related to parabola and see what the parabola turns out to be. Stay tuned for the next part.